All right, so we're talking about this force of gravity. And today what we want to do is quantify it and figure out how to find the force of gravity. From our lab, we did a graph of mass and the force of gravity, and we ended up with an equation that said F of g is equal to some constant, which in our case we found it to be 10 newtons per kilogram. That was the slope of our graph, times the mass. So what we can really do, that 10 is constant no matter what. That's something that doesn't change no matter where we are on Earth. So that's actually a constant in science. And we call this the gravitational constant. So G is equal to the gravitational constant, and it's measured in newtons per kilogram. M is the mass, and it's measured in kilograms. Now, G varies depending on the size of the planet that you're standing on. So in different places in the universe, G is not the same as it is here on Earth, okay, because it has to do with the force of gravity. So for example, on Earth, if you are at sea level, it's measured to be 9.8 newtons per kilogram. And that's pretty consistent no matter where you are on Earth. You can change it a little bit to maybe the 100th or 1000th decimal point, but it really doesn't change very much. It's a constant no matter where we are. Now in our calculations, we are going to use 10 newtons per kilogram because that just makes things a little bit easier. We don't have to worry about a calculator all the time. If we were to go to the moon is much smaller than the Earth. It has less of a force of gravity acting for it. And so the gravitational constant on the moon is 1.6 newtons per kilogram. So if we're doing a calculation where the mass happens to be on the moon, we wouldn't use 10, we would use 1.6. Now Jupiter's a lot bigger, and so Jupiter has more gravity. So its gravitational constant is much bigger than Earth's. It's actually 24.5 newtons per kilogram. That's quite a bit bigger, a little bit more than twice as much. So if you think about that, gravity pulling down on us here on Earth, if gravity were to increase by 2 times, that would be about the gravity on Jupiter. And then there's the sun. The sun is really big. And so if we could stand on the surface of the sun, then gravity would be pulling down with us with a force of 274 newtons for every kilogram. So probably not enough that you would actually be able to stand up. So as an example problem on your note sheet, what is the weight of a 25 kilogram object near the surface of the Earth? Okay, so what is our question asking? We're wanting to find the weight of a certain mass. And so that mass was given to us. We have 25.0 kilograms as our mass. So how do you find the weight? Well, weight is the force of gravity. And force of gravity is found by taking the mass times the gravitational constant. Okay, so we know mass, but what about G? What is that G? G is the gravitational constant, and since we are on Earth, that is going to be 10 newtons per kilogram. So from here, we just plug in our numbers. Force of gravity is going to be equal to the mass, which is 25 kilograms, times the gravitational constant on Earth, which is 10 newtons per kilogram. And so we're going to multiply that out, and we're going to get 250 newtons. Now, what if we're on Jupiter? Okay. Now, again, we're looking for the weight. So what is our weight on Jupiter? What is the force of gravity acting on us at Jupiter? The mass is still 25 kilograms, and we still use the same equation. The force of gravity, or the weight, is equal to the mass times the gravitational constant. But in this case, since we are not on Earth, we're not going to use 10 as our gravitational constant. We're going to use 24.5. So again, we're going to plug in those numbers. 25 kilograms times 24.5 newtons per kilogram. We're going to get 612.5 newtons. Now I want to talk a little bit about rounding here. When you punch your numbers into a calculator, sometimes it spits out a whole bunch of numbers. So we want to kind of come up with a convention to round to a specific number. And what we're going to do is we are going to look at the number of digits in the numbers in our problem. So for example, 25.0 kilograms has 3 digits in it. We are going to round our answer to the same number of digits. So since 25.0 has 3 digits, we're going to round our 612.5 to 613. So the weight of a 25 kilogram object on the surface of Jupiter is going to be 613 newtons.